Yeah, good day, everyone. I welcome you to another edition of Mathematic with Alimi Abdelakim. For today, let's go into this question. Said under bearing and distance, which is under trigonometry too. A ship sails from Port R on a bearing of 65 degrees, 065 degrees, to Port S at a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q at a distance also of 8 kilometers. Find correct to one decimal place B. Roman figure 1 distance between R and Q. Roman figure 2 bearing of Q and R. So let's solve this. We know for the basic what was it called? For the basic thing under bearing and distance, it is what? The cardinal point. So for this first one now, we talk about point R. That is the starting point for this particular question. It said on a bearing point R to point S on a bearing of 065 degrees. So let's draw our first cardinal point here. And we have this here. They said 65 degrees. This is what? Port R. I have this to what? North, south, west, and what? And east. So we are told that from port R to port S is what? 065 degrees. So I can have this like this. So it stops here. So what do we have here now? This is what? Port S. Since this is port S, I have this to become north, south, west, and east. So from here to here is what? 65 degrees. So let's now proceed from port S. This one is at a distance of 54 kilometers. 54 kilometers. Next one is what? They said it then sails on a bearing of 155 degrees from port S to port Q. We know from 0 to 90 degrees from north to east, while from 90 degrees to 180 degrees is from south to east. So what do we have here now? I have to draw another line, but the distance will be more than the one we have here. So I have this one here. I have this one here. I have this one here. When I have this one here, this is what? North, south, west, and east. So this one here is what? Port Q. And this is what? 80 kilometers. So the next thing I'm going to do here is I will join this R and Q together. So what do I have here? You don't mind my diagram. So we are told that from here to here is 155 degrees. And we know that for each quadrant is what? 90 degrees. So how do I get this remaining from here to here? That will become 155 degrees minus 90 degrees. What will it give us? So this one is what? 25 degrees. So this is 25 degrees. And we also know that for each quadrant is 90. So that means 90 minus 25 will give me what? 65 degrees here. And for this one now, this will also give me what? 65. From here is what? Alternate angles. Alternate angles. They're alternating each other. So that means everything here, everything here, this is 90. Sorry, this is 25. 90 90, this is 65. 65 degrees. So this one here become what? 65 degrees. Why this one here? 90 minus 65 will give us what? 25 degrees. So everything here will give us what? 90 degrees. So when we have this now, I've been able to get that. So the next thing I'm going to do is what? I will draw this shape into what? A triangle. Since what we have here is what? 90 degrees. And a three-sided shape that has an angle of 90 degrees is what? A right angle triangle. So let's draw our shape out. I have this, I have this, and I have this. So when I have this now, what do we do? Let's name them. This is 90 degree. This is S. This is what? R. And this is Q. So what do we have here now? This is what? 80 kilometer. And this one here is what? 54 kilometer. According to the interpretation of what we have in the question. So for the first question, I said calculate the distance, correct one decimal place, the distance between R and Q. That means from here to what? Here. So that's what we have here. What we have in a right angle triangle, and we have three sides unknown. If we have three sides, we are given two sides, and we are told to find the other side in a right angle triangle. Can apply what? Pythagoras theorem. So I'll be applying Pythagoras theorem, which states that hypotenuse square is equals to what? Opposite square plus adjacent square. So what do we have here now? What is my hypotenuse? That's line QR square is equals to what? Line QS all squared plus line RS all squared. What is my line QR? My line QR here is unknown. That's what we are looking for. Equals to what? My QS is what? 80 kilometers square. That is my opposite. Plus RS is what? 54 kilometer all squared. So what do I have here? I have my line QR all squared. 80 kilometers square. That was 6,400 kilometer square plus 54 kilometers square. That was 2,916 kilometers square. When I do my arithmetic on the right hand side, so what do we have here? I have QR all squared equals what? 9,316 kilometers square. So what's the next thing I'm going to do here? I'll take the square root of both sides. When I take the square root of both sides, I have this and I have this. So this will cancel this. So what do we have next? I have my QR. If you take the square root of 9,316, that will give us 90.5194 kilometer. And according to the question, we are told to find the distance between R and Q and correct to one decimal place. Therefore, line QR is approximately 96.5 kilometer, one decimal place. Thus, the distance between ports R and Q is 96.5 kilometers approximately. That's all. Let's look at the second one here. According to this case, they say find the bearing of Q from R. The bearing of Q from R. What does it mean? That means starting from here of Q from, that means starting from R, from R. This is the line for what? For Q. As we can see it here, this is the line for Q. So what is the bearing from here to here? So what do we do here now? For this second one now, bearing, the bearing of Q from R only become. So I can do something here. I can name everything here. From here to here equals to theta. Since I know I'm looking from this place to this place, and I've gotten from here to here. So what will it now become now? This will now become 65 degrees plus theta. How do I get my theta? So that means I have to go back to this right angle that we got here. I will apply my theta here. Since I'm looking for theta and I still want to use this same value here. So what am I going to use now? I'll be applying trigonometric ratio. Trigonometric ratio, which is what? SOHCALTOA. To apply SOHCALTOA, I'm applying tan. Because I have only opposite and adjacent there. So that will be tan theta equals what? Opposite over what? Adjacent. And I have my tan theta is equals to what? Line QS over what? Line RS. So I will have my tan theta is equals to what? 80 kilometers divided by what? 54 kilometers. So I have my tan theta. If you divide 80 divided by 54, that should give us 1.4815. So I have my theta equals to what? The tan inverse of 1.4815. So I have my theta is equals to what? 55.9810. So I'll have my theta is approximately 56 degrees. And that's what? One decimal place. We're not told to find theta, but we are told to find the bearing. Thus, the bearing of Q from R, it has been established as 65 degrees plus theta. And I've gotten the value of my theta here. That's 65 degrees plus 56 degrees. That's what? 121 degrees. That's all. Look at this one now. It's still in the second quadrant. That's from what? 90 degrees to 180 degrees. So I believe with this, we've been able to explain this question and solve it explicitly. So please, if you have any questions, kindly drop on the comment section below. Don't also forget to share, like, and subscribe. See you next time. Bye.